Hello and welcome to today's video. In today's video, I'm going to be going over how we could make a save load system using JSON within Unity. The reason I'm using JSON and not something like the binary, I'm not using something like the binary formatter is because Microsoft actually recommends not using it. They say it's not safe and it should just not be used. Now for your game, maybe that's not a big issue. You know, it only becomes an issue if you're sharing save files, but if your game gets big and players want to upload their save files on, to Steam Workshop or just on different sharing sites, there's no way to make those save files safe or check whether they're safe. So someone could upload a dodgy save file, a player would unknowingly download it, and then that could execute some code on their machine. So the binary format is out. So I'm using JSON. You could use something like XML if you wanted. There are ways to encrypt it. Our current save, when you look at a JSON file, it's fully readable here. Players can access this file and then they can change the data in it. So they could do, the X position of the player is 20.22222. So it's not safe in that regards. Players will be able to modify it. So then you'd have to look into sort of encryption. I'm not going to cover that here because at the end of the day, if you're going to be making a single player game, does it really matter if they change the data on their save file? If that's how they get their fun, let them. Even games like Valheim, for example, they use JSON. You can go in, you can change your server settings, you can change your player settings, and that's a multiplayer game. So, it's going to be dependent on everyone's kind of preference. I don't mind players being able to access their data. I'm only probably ever going to make single player games. So yeah, that's fine. And if I did want to go into multiplayer games, then you could look into encryption. So just before we jump straight into it, I'm doing this video as a standalone. You can follow this video if you've not watched any of my other videos. However, this is also going to be a prerequisite video for the save load system on my inventory series. So if you've been following along with the inventory tutorial series and you want to know how to save your inventories, you're going to have to watch this one. And then in the next video in that inventory series, we'll adapt the code that we've written here to actually make it apply to our inventory system. And if you didn't know I had an inventory system tutorial series, then why not watch it? I think it's quite good. People seem to be enjoying it. I'll put a little card up here to link you to the first video in that series. And just one last thing before we get started. I would highly recommend this official Unity video after you've watched this one. It talks about serialization in Unity and kind of what it all means and how it sort of works under the hood. But with that said, let's just get straight into this video. Okay, so here I am in the new Unity hub. I'm going to start a new project up here. If you don't have the new Unity hub, you can either, update it to get it, or I'm going to be using the first person core template. If you don't have this, what you'll need to do is just create a new URP project and then get this starter assets first person character controller from Unity. It's free, and you can get this kind of downloaded and installed. But if I pick the first person core, it's just going to do all of that for me. So let's call this save load tutorial and then come over to create project. So while that's loading and doing its thing, I just want to point out some stuff about script serialization other than what I discussed kind of in the start of the video. So here's the Unity docs for serialization. Just to go over it a little bit more, so serialization is the automatic process of transforming data structures or object states into a format that Unity can store and reconstruct later. Now we can save this out in a certain format, for example, binary, JSON, XML, but there are some different rules about serialization. There are some stuff that you can't serialize. So for example, we've got these are the rules to be able to serialize something. So a field has to be either public or private with the serialize field attribute, and it can't be static, const, or read only. And there are certain simple field types that can be serialized. So for example, custom structs with the serializable attribute, which is something we may use. We've got references to objects that derive from Unity Engine.object, the primitive data types such as ints, floats, doubles, bools, strings, enums, and certain Unity built-in types, so vector2, vector3, vector4, etc. You can serialize them out. And there are certain containers that can be serialized, such as arrays and lists. By default, dictionaries can't be serialized. And if we want to serialize a custom class, it has to have the serializable attribute. It can't be abstract, it can't be static, and it's not generic, though it can inherit from a generic class. So these are just some stuff to kind of, keep in mind when you're working on a save load system. So this is all loaded now. If I hit play, we can just see where we are, like what's going on. Here's the play window. So it's just a first person controller. I can run and jump. I'm just a little capsule. We can do something a little bit more interesting now, such as keeping track of the player's position and use that to save load, etc. So I'm just going to get rid of the README and let's just dock that up there. Okay, so let's go over to our scripts. I'm going to go over to the assets folder and come over into our scripts. These are the scripts that came with the template. I'm just going to right click, create a folder, and let's call this the save load system. So the first thing I'm going to do is I'm going to make a class. I'm going to call this class save data. So let's just create a C# script and we'll name this save data. Okay, so here's our save data script. Let's just get this nice and big. So the first thing we know is that for our custom classes to be serializable, they have to be marked as such. So we can, outside of the class, we need to put system, open a square bracket and do system.serializable, like that. And then we can get rid of mono behavior because we don't need the save data class to be attached to an object. And then let's bring that and get rid of all of this. And rider is telling me. So let's move this to the save load namespace. So we've got namespace, save load system. Save loads system. Let's rename this folder to save load system. And then let's open up our save data and rename that to save load system. Okay, so this is our save data. For now, I'm just going to put a public int in here, and we'll just call this index, and let's set this to 1. So this is serializable. It says in rider, it lets you know that it's serializable. I'm also going to have a serialize field, and I'll do a private, let's do a float, and I'll just call this my float, and we can equal this to 5.8 5.8f. Why not? So this is now our save data. Save data is very specific to your game. So I'm putting this in just so we've got something to work with, but your game's going to be different. Are you doing a top-down 2D game with a big inventory system, then you're going to need to store, the chests, what's in the chests, etc. If you're just doing, if you've got a custom map level editor, you're going to need to save a completely different set of data. So, there's no save button. There's no one click, just save the state of the game. You have to decide ahead of time what you want to be saved, such as your player's position, their inventory, their current health, all of the interactions they've had, keep track of NPCs and what they've been up to. But with that said, let's just get this set up and working, and then I'll show a bit more of a practical example of how we could maybe use this to keep track of some stuff to do with the player. This is our save data. I'm going to come back over to Unity, and in our save load system, I'm going to right click, create C# script, and let's call this one the save game manager, and then let's open up our save game manager. And again, this wants to be in the save load namespace. Let's get rid of this. So here, let's get rid of all of this as well. I'm going to zoom this back in, and I'm going to make this a public static class. And here, I'm going to have a public static save data called current save data. And we can set this equal to a new save data. And the reason I'm doing this is now we can keep track of this save data. We can access it from sort of anywhere. And that should be a capital C. So we've got our static save data, current save data. So now we need a way to be able to save this save data to file. So for that, I'm going to be using JSON, the JSON format. So there's some stuff we can do just to get this working. So I'm going to make a public static bool method, and I'm just going to call this save. And we can make this a new method. And let's just return true for now. So to save data out, it's actually very simple. So we're going to need somewhere to save it, which is a directory on the computer. So I'm going to make a public const string, and we can call this the directory. And we can set this equal to a new string, and I'm going to save it in a directory just called save data. This could be, you know, save games. This could be saves, save games. You know, you can name this whatever you want. And I'm going to make a public const string, and we can call this the file name. And I'm just going to do save game.sav. You can, again, you can make anything up here that you want. You could have, you know, you could just save it as a .text file. You could do .save, .sav. Like, it doesn't really matter. You can make up your own extension. But we just need to have that as a string. Alternatively, if you want to be able to save out stuff with different names, you could pass in a string and do file name as a string here. And then when you save it out, you could use this file name that you've passed in as opposed to a hard-coded one. But I'm just going to use the hard-coded one for simplicity's sake. So let's get rid of that. So the first thing I need to do is I need to make a temporary string called dir for directory. And this is going to be equal to the application.persistent data path plus our directory, which is this up here. Now, application.persistent data path is it's a set place by Unity, and it works cross-platform, and it's different no matter like which platform you're in. If you want to know exactly where your stuff's going to be saved, you can do application.persistent data path Unity. So you can see here that on the Windows Store apps, it's going to be saved in app data local packages. On the Windows editor and standalone player, it's going to go into our local low folder, which is our company, followed by the company and the product name. For Linux, it's, you know, it's different. You know, this is just one kind of call you can make, and then it's cross-platform, so you're not having to like hard code the actual directory for everything. So for me, this is going to go into my local low folder, and then it's just going to tag on /save data /. If we come up to edit project settings, and here we've got our save load tutorial. That's the product name, so that'd be the name of your game. Company name, let's just put this as Dampos. So looking at this, my save file on Windows is going to go to app data local low, Dampos, which is here, and then product name, which is here. So it'll be Dampos save load tutorial, and then it'll be in a save data folder within this persistent path. So now we've got this full like sort of path as a string. We can just say if the directory dot exists, so if this directory doesn't exist, okay, I've noticed an issue here. I've got this string called directory, and then I'm trying to get, but then directory is also a class, so that's why it's getting confused. So let's just rename this to save directory. There we go, that's fixed. And we need to be using the system.io namespace. And yeah, so if this directory doesn't exist, this dir, then we just want to make that directory. So we can do directory.create directory, and then pass in the dir. So when we call save, it's going to check what the full directory, including this folder that we're going to create. And if that doesn't exist, then we're going to make that folder. So that's the first thing that we need to do. And then we're going to come down here and we're going to say string JSON is equal to, and then we're going to use JSON utility dot to JSON, and we're going to pass in our current save data, and we're going to put in true here for pretty print, which will make it, without this, it puts it all on one line and it looks gross. So we want to have pretty print to true. And then we can just call file.writeAllText. And here we're going to pass in the directory, because this is the path that we're going to write all of the text to. So we need to do the dir, which is our full path, plus our file name. So this here is where if you took in a string as a parameter of this, you'd put the string here, as opposed to using the hard-coded file name. And the text that we're going to write out is our JSON string, which is this here. And then just to make this easier so I can open the folder, I like to do GUI utility dot system copy buffer is equal to our dir plus the file name. The reason for this is that when I call save, it's just going to copy the path to my clipboard, and I can just paste it into Windows Explorer instead of trying to navigate to the local low folder, because it's a bit of a pain in the butt. You know, for now, that's our save system done. It's going to save out here, and we're returning true, just to say that it was successful. You may want to put in some, other checks, and it could return false if something's going on. For example, if the scene's loading, you can put some different checks in. But this is just so we know that the save has been completed successfully. So we now need a way to call our save function. So let's go over to Unity again. I'm going to right click, create empty, and let's just call this our save tester. So back in Unity, I'm going to make just a button that will allow us to just click the button and then we can save the game. So if I come up to, if I right click, in the project, do UI, and just make a new button, and let's just call this the save game button. And then let's find this in the scene in 2D mode. Oh. And I'm going to make the canvas screen space overlay, that's fine, but I want it to scale with the screen size, and then I'm just going to put in 1920 by 1080. And then let's get our button. And I'm going to move the button just down here. And let's just scale it up slightly. And for our text, let's do best fit just to make it a bit bigger, and then we'll just put in save. While we're here, I'm just going to make a load button as well. Load game button, which we can't use just at the minute, but we will be able to use it in a second. So let's go to our load text and just put load here. Now on our canvas, I'm going to make a new script. I'm going to call it just a save game tester. Now you might want to call this the save game manager, or wait, we've already called that the save game manager, but you know what I mean. So this save game tester script, this may be your game manager script. You can plug this in, kind of this functionality into whichever script it kind of makes sense to do so on your own game. But for me, I'm just gonna here make a public void save game function, and when this function's called, it's going to access our save game manager, and it's just gonna save the game. Now, if I come back over to our save game button, and on click, we want to find our save game tester script and just call the save game function. Let's just add our public void load game function here, and we can do save game manager dot load, which we haven't actually made yet. So let's just load game here. So with our load game button, come down to on click, drag in our canvas, and then just hook in the load game function, which again doesn't do anything at the minute, but it will do. So if I come back over to our game, let's just set this to 1920 by 1080. So if we hit play now, you know, we can walk around and I can hit the save button and our game is going to save. So if I hit save, did that work? I can't tell if that button actually pressed. Let's just disable our player capsule for now. I don't want it to capture the mouse. If I hit save, there we go, the button is saved. And because we put the system.copy buffer in, oh actually, this needs to just be the directory. It doesn't need to be the file name. That is my mistake. So let's just save that and reload, and let's do that again. So if I hit play and hit save, so that's going to have copied the directory to our clipboard. So I can just come up here and paste that in. And you can see that it's gone into app data, local load, dampos, save load tutorial, and our save data folder. And we've got our save game file here, which is a .sav file. If you want to get to this folder without copying it to your buffer, on Windows anyway, you can press the Windows key, type in run, type app data surrounded by the percentage signs, click OK, and then you've got to come back out to app data, go into local low, find your company name, your project name, and then the actual folder. So, you know, it's just quicker to be able to just paste that in and hit enter. Now let's open up our save game. And here's our save game. So we've got index, which is 1, my float, which is equal to 5.8f. It's added some extra stuff onto the end of it. But, you know, that's fine. So let's just come back out of here. So now we can put some different stuff in our save data as well. So we can do, for example, a public bool. Just call this our bool, set this to true. Do a public vector 3 called our vector, and then maybe set this to a new vector 3 of 0, 10, 99, which again is marked as serializable. So let's just close this down, hit play. Hit save. Make sure we close this. Go back over to our project and open up our save game. So now you can see that we've got an index of 1, my float, our bool, our vector. So that's how you save out data. So how would we load this? So if I stop the game, let's work on loading the data now. If I come over to our save game manager. So what we need to do now is we need to make a public static void load. And let's just do save game, load game, and let's just rename this to save game. Just so we're a bit more explicit about what we're loading and saving. So we've got load game, and we can do string full path, and this is again equal to our application.persistent data path plus our save directory, and then plus our file name. So this is the exact file that we want to be able to load. We're not loading the directory, we're loading in the save data, so we need to have the file name included. Again, if you've put a custom file name in here, you'll have to check that custom file name in load game and pass that in as well. So we now need to make just some save data called temp data We'll set this equal to a new save data. And we can say if file.exists at our full path, so if we have a save game here, then we want to recreate our JSON. We need to load in our JSON string. So here, just as we saved it out, we want to recreate it as a JSON file. So we can do string JSON is equal to file.readAllText at our full path. And then we need to convert this JSON back into some save data. So we can say temp data is equal to JSON utility dot from JSON, and we want to open up some angle brackets, and this is going to be the type of save data, and we'll pass in our JSON path. So we're getting our JSON string back into the program, and then we're using the JSON utility to turn that string back into our class, our custom class of save data. And if the file doesn't exist, let's just debug.log error save file does not exist. And then at the end, after all that, we can do current save data is equal to our temp data. So let's just check that's working. So in our save game tester, what I'm going to do is I'm going to do save game manager dot, and then let's get the current save data, and let's change the index to 10, and then let's save the game. So let's just make sure that's working. So our current data index is 1. So let's just make sure that's closed. So let's hit play. And then let's hit save. And let's check our save game data now. So index is 10, so we've changed that. Now let's check the loading is working. So if I do here in our load game, what we can do is do save game manager dot load game. So before I load the game, let's change the index again to 20 this time. And then let's load the game, and now let's debug dot log the save game manager dot current save data dot index. So what should happen here is we've changed our index to 10, and then we've saved the game, and then we're going to change it again when we load it to 20. We're going to load the game and then print it, and if our load game's working, it'll print back out the 10 that we've saved, and if it isn't working, it'll print out 20 because it won't work and we've changed it to 20. So let's just check that. So again, we'll hit play. Let's come over to the console. So let's save our file out. And let's just check. So it's definitely index 10. And now let's load our game. And you can see here that it's debug.log 10. So even though we set it to 20, after we've loaded the game, it's actually 10. So that shows that our index, our save game system's working. Okay, so this is all working. So how can we make this a bit more game related, not just a bunch of just useless junk? So let's get rid of all of that and just save our file. So in our scripts folder in our save load system, oh yeah, and then because that's because I've deleted all that data, we just need to get rid of this. So let's make a custom struct now of some player information. So if I come over to our player capsule from this starter asset and just re-enable that. Okay, so I'm going to add a new script to our player, and let's just call this player save data. So in our player save data script, outside of the class, I'm going to make a new struct called public. I'll do public struct, and we'll call this the player data. And we need to mark our struct as system.serializable. And now we can define what we care about on our player. So this is where you'd save out their, their current inventory system, their position. So we can do a public vector 3 player position. We could do public int player current health. And you can do lots of different stuff in here. You can, again, it's very specific to whatever your game is that you're working on. So I'm just gonna, I'll just leave it at player position and current health. They're two good sort of test cases. So now back in our save data class, I'm gonna make a reference to public player data called player data, and set this equal to some new player data. So now in our player save data, I'm going to here make private player data and do my data and set this equal to some new player data. Now in our update function, we can say my data dot player position is equal to transform dot position. We could maybe do as well a public quaternion player rotation. And then we can do my data dot player rotation is equal to transform dot rotation. So every frame, we're going to be keeping track of our player position. So this is going to be like a constantly saving thing. You might not want to do this on every frame. You may want to set up your own kind of custom event. So every 30 seconds, it logs the player position. So if you've got an autosave system, that's a good way of doing that, or like a checkpoint system. When a player passes through a checkpoint, then you'll need to update this. But I'm just going to do it every frame, and I'm going to say that if and then let's do current health as well. My data dot current health is equal to current health, which is going to be a public void, public int current health. Well, let's just default this to 10. We could say if keyboard dot current dot rkey dot was pressed this frame. So this is using Unity's new input system, which is enabled by default with the first person template. If you're doing this in your own game and you're not using the new input system, you'll just do like input.getKey down, key code R. But this is using the new input system, so that's how you do that. So if the keyboard.current.rkey was pressed this frame, then let's call our save game manager. Let's actually make a new. We're gonna have to do a couple of things. So we'll do save game manager dot current save data dot player data is equal to my data, and then we'll do save game manager dot save game. So every frame is going to be updating the player position, the player rotation, and the current health. And then when I press R, we're going to set our save games current save name. We're going to set our save games current save data dot player data, which is this struct. We're going to set that to my data, which is this version that we're keeping up to date every frame. Something else that you could do is, instead of doing my data, you could do the save game dot current save game dot player data and update that directly. I think this is a good way of just keeping track of this, keeping it all in one script, and then updating the save game manager when needed. So we can set our player data equal to my data. And then I'm going to do if keyboard dot current dot I'll just do the T key. The reason I'm using random keys is because I don't know what's like WASD space and all that set up already. I think R and T should be fine to use. So if current dot T key dot was pressed to this frame, then we're going to do save game manager dot load game. And then we can say my data is equal to the save game manager dot current save data dot player data. And then from that, I can say transform dot position is equal to my data dot position. I can do transform dot rotation is equal to my data dot player rotation. Player rotation, and then I can say current health is equal to my data dot current health. And rider is telling me to cache my transform, so I'll do that. So let's go over to Unity now, and I don't actually need these save game buttons because I can't use them when the capsule's activated. So if I hit play, so we're walking along, we're updating our position. Let's select our player capsule so you can see our position up here. Let's go over here. So -15 on the X, below 1 on the Y, -1 on the Z, and we've got a Y rotation of 84.95. And our current health here is 10. So if I hit the R key, that's going to have saved our game, and it'll have copied the directory to the path. I'm already there. Open up save game, and we've got player data. So player position, -15, just -15. Y, 0.89, blah, blah, -1, that's all good. Current health equal to 10. So if I now change our current health to say 5, and then I run over here, and I hit the T key, it's going to load our game and reset our player's position, rotation, and health. So do T. You can see it's loaded us back, and it's put us at -12. Is that where I was? Okay, that was a bit of a pain in the arse. Okay, so there was a bit of an issue with our function. The problem was that with the first-person controller template, this first-person controller script, so somewhere in this script we're setting the position with the character controller. I think it's here, this controller.move. Obviously, that's the bit that's moving the player. And this is called every frame. Now, what was happening is that we'd hit the load button, and then it would set our position to my player.position. This was all loading fine, but then immediately on the next frame, there was a bit of like a hangover kind of somewhere in this script, and it'd move you back to the frame that you just were, and you'd have to press load a few times for you to be the one that got called last, and actually for the save data to overwrite the actual data. So one solution for this is I've got a reference to our first-person shooter controller, which is our first-person controller here, and I'm going to get that component in the awake function. And then what I'm going to do is got keyboard.current.t key was pressed this frame. I'm going to disable the controller. I'm going to do all of our jazz and set the transform, etc. And then after 0.25 seconds, I'm going to re-enable the controller, which will basically stop this overwriting what we're doing here. So while the game is saving, none of this is going to be happening. And then once it's finished saving, we've just got a little bit of a buffer to re-enable this. Another way of doing this would be in our save game manager, have some, public static Unity actions, like on save game, on load game start, and then we could have on load game finish. We could call on load game start dot invoke here. After it's finished loading, we can do on load game dot finish and invoke that. And then in all of the scripts that need to know when a game's loading, I'm going to get rid of this. This was just for me trying to fix it, because that didn't seem to work for some reason. So in all of our scripts here, we could subscribe to our onEnable. We could subscribe to our save game manager and detect once the game started loading, do some logic based on that. And then once the game is finished loading, re-enable anything that we need to actually enable. But for our case here, this works just fine. So let's go back over to Unity and let's see it not work now and be a pain in my butt. So I'm going to come over here. I'm going to save the game by pressing R. We can look at the save data file. So we've got current health 10, our rotation and position, that's all the same. The rotation's changed because obviously I looked down, but that's all groovy. Now, if I come back over to the game, I'm going to change our health to 3. I'm going to run over here. Let's come in here, and then I'm going to press T on the keyboard, and that teleports us back, and we can carry on moving. And we've got all of our health back. Let's, go up. So we've got 20 health now. I'm going to come over here. And I'm going to save it looking up this staircase. So press R to save the game. And I'm going to run back out here. Press T. And there we go. We're looking up the staircase. And we've got our health back. Our health stayed at 20. If I set this to 10 and then press T and load it, there you go. Looking up the stairs, got our 20 health back. So from this point on, it's kind of up to you what you want to do and what you class as needing to save. This is just a good kind of example of that. We've got our player save data, and like I said, you could have your inventory system. The amount of gold that the player's got instead of the health, the unlocks that they've got. You could have a public bool double jump acquired. This could be, and then you can get your double jump, and then you'd keep track of that here. You can do whatever you need to do, keep track of, completely up to you. But yeah, if you've got any questions, do let me know in the comment section below. If you want the project file for this, so you can play around with it and have a look at how I've set stuff up, that will be available over on patreon.com/danposs. If you've got any issues with the project or any questions that you want clarified, let me know in the comments below, or head over to the Discord server, which is linked in the description, and I should be able to help you there. But in the meantime, thanks for watching, and I'll catch you in the next one. Bye.